Hello everybody, thank you for watching. This is 2.2 video on isotopes. The main objectives for this video is to try to figure out what does the word isotope mean and how does it relate to our subatomic particles that are inside an atom. So let's start by reviewing our atomic structure that we talked about in our last video. We know that this is an image of an atom, and in the center of an atom we have our nucleus. In this particular atom, we have 2 protons and 2 neutrons that are located inside of our nucleus. We also talked about our masses. We know that protons have a mass of 1 AMU, and our neutrons also have the same mass, which is 1 AMU. Our electrons are so super small that they basically have no mass at all. So most of the mass of an atom comes from our protons and neutrons, which is the nucleus. So we want to ask ourselves, what makes this an helium atom? Is it the 2 protons? Is it the 2 neutrons? Or is it even the 2 electrons? The answer to this question is it's actually the 2 protons. So the number of protons inside any atom determines what type of element it will be. And this is one of our key ideas. So the next thing is kind of like, what if we wanted to add more neutrons to this atom? We can add 1 neutron, we can even add another neutron, we can even add some electrons if we want. The point is, it does not change what this atom of helium is, because only the protons determine what the element is going to be. You can add as many neutrons as you want, you can add as many electrons as you want, it still is going to be an helium atom. So let's now revisit what we think isotopes are. So we know now that the protons determine the type of element an atom is going to be. So let's model 3 different helium atoms. We know that each of these atoms have to have 2 protons because we're sure that if it has 2 protons, it definitely is going to be an helium atom. What we can change is the number of neutrons. For the first atom, we can have 2. The second one we can have 3, and the fourth one we can even add 4. Notice that it still is helium atoms. It does not change. One thing that I do want to show you is the masses of these 3 atoms are different now because our masses come from protons and neutrons. So the first atom has a mass of 4, the second atom has a mass of 5, and the last atom has a mass of 6. These are all isotopes of helium because the number of protons are the same. You can add as many neutrons as you want. You can even change the number of neutrons. It still is going to be helium. So what about our electrons? We didn't really talk about what if we change the number of electrons. You can see for these images right here, I put different numbers of electrons on all 3 of these atoms. The key thing is that the number of electrons do not affect the type of isotope it's going to be, and it does not change the mass because if you remember, our electrons barely even have a mass. So it's not going to change the isotopic status of our different atoms, and nor is it going to change the mass. So I think we're ready to define what isotopes are. So if we revisit our 3 atoms of helium, we can state that isotopes are atoms with different number of neutrons, but the same number of protons. And like we said, our electrons really don't matter. You can also define isotopes in another way, and you can say that isotopes are atoms of the same element, but with different masses. So this is a quick recap of our isotopes video. Please pause the video and revisit things that you find confusing. Thank you.